Okay, let's say that you claim that the proportion of black dice in the bucket is greater than 0.3. Whoops. So we're going to assume that it's equal to 0.3, and the alternative hypothesis will be the proportion is greater than 0.3. So remember, your null hypothesis is always going to be a statement that contains equality, and the alternative hypothesis is going to be something else, right? So it's usually what your research is going to be about is what your alternative hypothesis will be. So we believe that it's greater than 0.3, but we're going to assume that it's equal to 0.3. So let's pick a significance level. So let's pick a different one so that we get a different confidence interval. Let's say, let's make alpha 0.02. Okay. Now, if it's a right-tailed test, or now if our alternative hypothesis has greater than or less than in it, our confidence level will be 1 minus 2 alpha. So this would be 1 minus 0.04, which would be 0.96 or 96% confidence. All right, so let's take a sample. We can use the same sample here. Let's look at the frequency of black dice. So we got 39 black dice out of 100. So that's a sample proportion of 0.39. So we got 39 out of 100 for a sample proportion that's 0.39. Now that is bigger than 0.3. The question is it far enough away? Is it a significant difference? Okay. So we need to make our bootstrap confidence interval, and we're going to see if that confidence interval contains 0.3, or is that entire confidence interval above 0.3. If it is, then we'll support the alternative hypothesis. So I'm going to go to applets, resampling, bootstrap-based statistic. I'm going to use proportion, 39 out of 100. I'm going to run the simulation. Right, so our confidence interval is not actually up here, right? It's not automatic. So we need to find the percentiles ourselves. Now let's talk about what we would need for 96% confidence. So in the tail here, we would have 0.02 and 0.02, and in the middle, we'd have 0.96. So we need the second percentile, and we need the 98th percentile, right? So those two will give us our confidence interval. So I'm going to, I don't have the second and the 98th. I mean, these are close, but I'm going to click Analyze. And when I did that, I got all the bootstrapped sample proportions. I'm going to go to Stats, Summary Stats, Columns. I'm going to pick that new column. And I don't need any of these. I just want the percentiles. So I want the second percentile. And I want the 98th percentile. And it tells me that that is 0.29 and 0.49. So 0.29 and 0.49 is my confidence interval. So 0.29 to 0.49. So we're going to look at our assumption for the population proportion. Is that inside our confidence interval? It is. So we're going to say do not reject or fail to reject the null hypothesis. And we do not have enough evidence. We'll say there is not enough evidence to support the alternative hypothesis. Okay. Now it's close, right? So we got, this goes all the way to 0.29. If we'd picked a higher alpha, maybe 0.05 or 0.1, then we're probably going to reject in that case. So you don't want to go backwards. You don't want to make the confidence interval to fit what results you want to get. You want to start out with how what's my tolerance level for making the type 1 error? That's alpha. I only want it to happen 2% of the time. And then you make your confidence interval and you just accept the results. Okay, let's do one for the mean. Let's say we claim that the population mean weight is less than 4.9. So we're going to assume that it's equal to 4.9, and we'll make a confidence interval to check to see if we get something significantly less than 4.9. Okay, so let's pick a different alpha. How about 0.01? So again, on a less than or greater than alternative hypothesis, we're going to pick our confidence level to be 1 minus 2 alpha. So it'd be 1 minus 0.02. So that would be 0.98, which is 98% confidence. In a bootstrap sample, we need what percentiles? So there's 98% in the middle, 1% on the outside. So this would be the first percentile. This would be the 99th percentile. So that'll be our confidence interval limits. Okay. So again, let's find the mean of our sample weights. So I have sample weights here. I just want the mean. And I got 4.6363. So in a sample of 100 weights, I got a sample mean of 4.6363. That is less than 4.9. So now we just want to make a bootstrapped confidence interval, find the first and 99th percentiles of those samples, of those sample means, and we'll check to see if 4.9 is in that interval. So applets, resampling, bootstrap-based statistic. We're going to use the sample weight again for the mean. I like to do 10,000 samples. And we don't have the first percentile, we don't have the 99th. So we're going to click Analyze. And it gives us a new column with all those sample means in it. We need to find the percentiles using summary stats. So I'm going to find the first percentile and the 99th. I don't need all this other stuff. I'll just find the mean. And I get 4.5 to 4.774. Let's round this to 1 decimal place, so 4.5 to 4.8. So in my 10,000 samples that StatCrunch simulated for me, 90 8% of them had a sample mean between 4.5 and 4.8. 4.9 is not in that interval. So we're going to reject the null hypothesis, and we're going to say there is sufficient evidence, or enough evidence, to support the alternative hypothesis that the mean is actually less than 4.9. So we believe that the population mean is less than 4.9. Right, now if you adjust alpha, if you make alpha bigger, then your confidence levels will be lower and your confidence intervals will be narrower, right? So that will affect whether or not you reject or fail to reject. So but you just want to pick alpha first and go with it.